Let's see how we can solve this equation with factorials. Here we have n plus 1 factorial minus 20 times n minus 1 factorial, and that's equal to 0. And here we want n to be positive, because in fact, when we have negative n factorial, negative whole number factorial, that's not defined. But that will be another topic for another video. Here, what can we do? Maybe we can use the usual breakdown for factorials. What I mean by that is the following. Suppose n is a positive whole number. Let's say 1, 2, 3, so on, so on, so on. Then the usual breakdown for n factorial is that you start with the number n times the next whole number, which is just n minus 1, and then times the next one, which is n minus 2, so on, so on, so on, up to, once you hit 1. So, real quick, for example, if you have 5 factorial, this is just 5 times 4 times 3 times 2 times 1. Work that out, you will get 120. All right? Now, if you have 0 factorial, you can say by definition this is equal to 1, or by pattern this is equal to 1, however you want to say it. If you want to see a better explanation on that, that will be another topic for another video. Okay, you want to see this? Okay, I'll show you. 5, 4, 3, 2, 1, 0. Yeah? Now, what's happening on the right-hand side here? From here to here, if you just look at the results, you can look at this as divided by 5. You can look at this from 24 to 6 as divided by 4. And then divided by 3. And then divided by 2. 2 divided by 2 is 1. Now, to get to 0, yeah, we will take 1 divided by what? Divided by 1 in order to get to the 1. So this is by the pattern. Alright, anyway though, this equation, in fact, it's easier than it looks. But you have to know how to simplify it. I actually prefer to have a ratio of the factorials because we can reduce that better. That's just my preference. So I'm going to move this term to the other side. We get n plus 1 factorial equals positive 20 n minus 1 factorial, and then let's divide the n minus 1 factorial to both sides. So that way this and that cancel. And then to simplify factorial by using this, let me tell you, go ahead and break down the bigger factorial. N plus 1 is bigger than n minus 1, so break down the top one. Break this down, I'm going to start with n plus 1, and then the next number is just n, and then the next number is just n minus 1, and then n minus 2, so on, so on, so on, up to 2 and 1, and over n minus 1 factorial, and that's equal to 20. Now, notice, this part right here is really just what? We started at n minus 1 times the next number, times the next number, all the way down to 2 and 1, right? This is really the same as n minus 1 factorial. So don't even bother to break it apart. Otherwise, you have a lot of things to cancel. I'm just going to cancel all this with that. So in fact, we will just end up with this times this, it's equal to 20. We can distribute, so that's n squared plus n. Move the 20 to the other side. So in fact, we have a quadratic equation. It's actually nicely factorable. N plus 5 times n minus 4 is equal to 0. Oh yeah. 0. And then from here, you can see that n is equal to negative 5. And from here, you can see that n is equal to 4. But as I mentioned earlier, we'll just be looking for the positive n. So therefore, n is equal to 4. And just get rid of the negative number, right? And if you plug back in to the original and check, you can see that this is 5 factorial, and then minus 20 times, this is 3 factorial, like this, 3 and then factorial that. Okay, this is, I have the answer right here, it's 120. And then minus 20 times 3 factorial is 6. So do we get 0? Indeed we do. So it works. If you plug in negative 5 into the original, you will end up with negative 4 factorial, and technically that's not defined.